Hello and welcome to Note 7. This is our intro to fractions. A fraction, let me get a pencil. A fraction is a numerical representation of a quotient of two numbers. It represents a portion over the part of a whole quantity. The top number of a fraction is called the numerator. The bottom number of a fraction is called the denominator. And it is important that you know those two words. Well, most of you already know them, but it is important because when we talk about fractions, sometimes you have to get a common denominator. It's kind of good to know which part that is, right? Now, when you broke this circle up in, a little pie into 8 pieces, right? That's the whole or the denominator part of our fraction. And this colored area is supposed to be the portion that we're trying to represent. So the fraction 3/8 is the way that would be represented. Fractions are said to be in simplest form if all the common factors are canceled out. For instance, if you had a fraction and you broke the numerator up into prime factors this way, a times k, and the denominator into its prime factors, b times k, if you have common factors, you're allowed to cancel them out. And that's how you get what is known as simplest form. And that's what we want to shoot for. We always want to make sure that our answers are completely simplified or in simplest form. So let's do that on these examples right here. I'm going to start. I'm not going to show the prime factorization for every single number, but just know that that's what I'm going to write out. Okay, so you can do your prime factor trees and write them out that way. If I have the fraction 6/10, I can write the numerator out this way, 2 times 3, as that's the prime factorization of 6, and 10, 2 times 5, that's the prime factorization of 10. And notice how they have that 2 in common. And what's left is the simplified form, which is what we're looking for. Another way, and I do want to show this because some of you are a little more insightful and you're probably ready for this. If you see that there is a number in common that you could divide out of the numerator and denominator, you can go ahead and do that. You can say, I can divide a 2 out of both the top and the bottom, and you'll still get the same simplified form. So whatever you're ready for. For -4/12. Now, if you have a fraction, -4/12, the simplified version is still going to be negative, right? You're not changing it sign-wise. You're just changing its appearance to its simplest form. So I'm going to keep the negative, and then I'm going to write the prime factorization of the the fraction down. 4 is 2 times 2. 12 is 2 times 2 times 3. Now remember, for every number on the top, one number on the bottom can be canceled out. That's called a common factor, and you're canceling them out. I wanted to show this one this way because what if you cancel all of the things in the numerator out? Remember, all of these numbers have prime factorization of 1 times itself also, don't they? So there's actually a 1 left over on the top. And so the reduced or simplified form for that fraction would be -1/3. For 6/15, I noticed that they both have an extra 3 in common that I could divide off, so you can do it that way. And I think I want to try it on this one. Oh, no, let me go ahead and do the prime factorization of it. That is 2 times 3, and 15 when it's negative, so -3 times 5. They do have a 3 in common that can be canceled out, and so I'm going to be left with a -2/5. Now, if I have a negative over a negative, that's actually going to be a what? A positive. That's correct. Because a negative divided by a negative is a plus. I can go ahead and turn that into a plus there before I solve the problem. And I want you to see if you can get to the point where now you can look at it and say, I can divide a 2 out of both of those. Let's show this one that way. If I have 8/28, now I know it's going to be positive if I notice that they're both divisible by 2, I can go ahead and divide a 2 out of top and bottom. That's going to leave behind a 4 and a 14. But then you look at that answer and you're going to say, wait a minute, they're both still even, which means I can divide a 2 out of both top and bottom again. 4 divided by 2 is 2, and 14 divided by 2 is 7. That's the simplified form. Or, and again, this is the last one I'll do both ways. You can still have written the prime factorization out. 8 is 2 times 2 times 2. 28 is 2 times 2 times 7. Notice that if I cancel the 2's out, I do get the simplified form that I got above doing it the other way. So it's really going to be your preference. Now, for 6x and 2x, immediately I notice that they have an x in common. I'm going to go ahead and cancel that. And now 6 is 2 times 3, and 2 is just 2. I'm left with a 3, and don't forget, if ever everything cancels, you still have a 1. But 3 over 1 can be reduced down to just 3, can't it? Okay, for number 6, first thing you do is cancel out those x's that they have in common. 12 has a prime factorization of 2 times 2 times 3. And again, I'm not going to spend a lot of time doing the prime factorization because you know how to do that. Stop the video and do that part ahead of time if you would like. And 18 has prime factorization of 2 times 3 times 3. They have a couple of 2's that cancel and a pair of 3's that cancel. So the simplified form of that number is 2/3. Let's go straight into multiplying fractions. To multiply fractions, we can multiply the numerators together and we can multiply the denominators together. Notice it looks like it's just going straight across, and that's exactly the way that I want you to think about it. You multiply straight across. Now, we are still doing this without a calculator, so again, keep sharp on your times tables and this should go pretty well. Now, the other thing I want to point out is that we are also allowed to do cross-canceling of common factors. So when you're multiplying, you can still reduce within a fraction, which is what we practiced above. And now we can also cross-cancel. So I'm going to show that so that we make sure that we keep these problems as simple as possible for ourselves. So when I multiply -5/12 times 1/3, first thing I notice is that 5 and 12 don't appear to have anything in common that I can reduce. Neither do 1 and 3. And then I look diagonally. 12 and 1 don't have anything in common. 5 and 3 don't have anything in common. So the answer here can be found by just multiplying straight across. First though, a negative number times a positive number is going to be negative. 5 times 1 is 5. And 12 times 3 is 36. That's it. Now for number 8, look to see if you can reduce anything within each fraction. No. Can I reduce diagonally? Yes. This 5 and this 5 cancel, and they leave 1's behind because I still need something to be sitting there, right? Now you can multiply straight across. 1 times 6 is 6, and 13 times 1 is 13. Now, what if you say, Miss Lopez, I didn't notice that? That's okay. Watch this. I mean, it's a lot easier if you will check that ahead of time. But what if you didn't? Oh, that was a 5, wasn't it? If you didn't, and you multiplied straight across, you're going to get 30 over 65. And then you're going to have to reduce. It's a little easier if you'll cross-cancel and reduce ahead of time. On this one, though, I could just start and I could say, okay, I'm going to divide the top and bottom by 5. And that's going to leave me with a 6 and a 13. So you can still get back to the same answer. As we go along, I'm going to encourage the cross-canceling because it makes your life so much easier. Let's do this one. Check to see if you can reduce either fraction like we did at the beginning. 5 over 6 and 3 over 4 don't reduce, so I'm ready to multiply straight across. Or wait a minute, sorry, I forgot to check the diagonals. 5 and 4 don't have anything in common that I could reduce. Do 3 and 6 have anything that you could reduce? They can reduce by a factor of 3. If I divided 3 by 3, it's going to leave behind a 1. If I divide 6 by 3, it's going to leave behind a 2. And I can multiply straight across. That's going to leave me with 5 over 8. That's the advantage of cross-canceling. Let me do it one more time, both ways, so that you can see. Oh, I wrote that wrong. All right, guys. 5 over 6 times 3 over 4. Let's say I didn't notice the cross-cancel. That's going to give me 15 over 24, and you're going to lose points if you don't reduce it. So you want to go ahead and reduce it. Let's see, 15 and 24 both have a 3 in common. So, or you can write the prime factorization out, and I guess I could do that. That's 3 times 5, and 24 is 2 times 2 times 2 times 3. The 3's cancel, and that's how we end up with 5 over 8. And again, a little bit longer process, so it really is to your advantage to reduce ahead of time. Let's do it on this one. I'm going to start with the signs. A negative times a negative is a plus. Okay, they're gone. Now I'm just dealing with the numbers. For 2/3 times 9/8, 2/3 doesn't reduce, 9/8 doesn't reduce, but remember, it's always to your advantage to check the diagonals. Do 2 and 8 reduce? Yes, by a factor of 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Do 3 and 9 reduce? Yes, by a factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now when you multiply straight across, you do get 3 over 4. And one last time this other way. If I had negative 2/3 times negative 9/8. Again, first thing I'd do is make sure to get rid of the negatives. And if I multiplied straight across right away, I'm going to get 18 over 24. And then you can do the prime factorization. That is 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. In reducing it, I see 2's in common, I see 3's in common, and you're left with 3 over 4. Same answer. That will be up to you. All right, I'll see you in the next video.